So one other point I wanted to say is you need to be careful with the type that is resulting from variable conversion or from type conversion. What happens if we try to mix different types? Now, so as you see, when you have a plus operator, on its left, on its right, they may be of same type or maybe of different type. So what happens if you put a float and an integer, right? Mix one on one side and the other on the other side. What happens? Then you need to be careful because it will take the result and then convert it to the more general type or the less lossy type. And in this case, between float and int, float is more general or less information loss in a sense. And so the resulting type would be a float. In fact, strictly speaking, it should be a double. Now we can do this experiment. Mix int and float. So int and float gets float. So int, we can use x, and then int we use a, right? A because of the int a, right? A gets x. Now float, we can use the original one, which is y, right? And then a plus y. And then let's see what happens. Okay, so enter two floating point, 30.6, 15.2. Okay, so what we're interested in is mixing int and float. So int 30 plus float 15.2 is 45.2. Okay, so what you want to be careful with here is you don't want to change this to a decimal, right? The result type a plus y. This expression has a type. And in this case, it is the more general type, which is float. But if you try to print it as decimal, then it's going to be incorrect because it's taking a quantity that encodes a decimal, it encodes a floating point number, and then try to print it as decimal, and it's going to be something that doesn't quite make sense. Let's try it. And in fact, you get a warning because the compiler knows, hey, here it's a floating point, but you're trying to format it as a decimal. It even tries to make a suggestion for you. See, not all compilers, not all C compilers do this warning, but more recent ones are smart enough to do this. And if it doesn't do it in your default configuration, what you can do is to do warning with a minus big W and then with like a format or all, okay? But it's a warning, which means it will probably still let us run. So we can do 30.6, 15.2. And guess what? Now it shows 30.6, 15.2 equals 0 with this %d rather than 45.2. And the reason is because whatever you get is not really interpreted properly. Okay, it's looking at a different part of this resulting floating point number. Okay, so it's incorrect. And so the thing to do is to follow the compiler's advice, change this one back to a %f to properly match the type. Now, but if you really want to force this result here, even though it's a float expression, if you want to force it back to an integer, you could. The way to do it is to use int and then do what's called typecasting. And this says this expression, whatever it is, well, in this case, float, force it back to an int. And this allows us to then print it as an int. Okay? And what happens is it will do what you may expect. That is, it will do truncation. So let's do the compile again. A.out. If we do 30.6, 15.2, see, we are adding an int and a float, but we put the result back. Whatever it is, it then gets converted to an int by truncation. Because what we got before, as you probably saw, was that this was the 45.2, which gets truncated down to 45. Now let's try another example, or another test case, right? Let's do 8 and 15.4. What do you think is going to happen? Well, so it's still 30 rather than 30.8, and 15.4 is 15. So we never get above that 45 point something. So it still truncates it. Okay. So now let me make one other change to this one. So we do add original floats, then convert to int. And then we do %f, %d. Here I'm gonna wrap the long line, and then so I put x plus y, and then int x plus y, right? So you see, x is the original number, y also original input number. We're doing x plus y, which is a float, but then we force it to be converted to an int. And then let's see what happens. Okay, so this is the additional line that it will print. And if we type in the 30.8 and then 15.4, you see, now because it does the truncation not before but after you add. So it does the 30.8 and 15.4, which is 46.2, and then truncates it. That's why it's 46 rather than 45, right? So in the case of the second-handed floating point, the truncation happens before you do the add. In this case, the truncation happens after you do the add. So it was 46.2 truncated down to 46. So as you see, you need to be in complete understanding of exactly what C is doing at each step. Okay, these look like very minor differences. Sometimes they might look almost identical, right, in their format, in their sequence. But a little bit of subtle difference can make the biggest difference in the world. Okay, And sometimes these are very subtle because a lot of times you don't discover the error of truncation because you didn't have anything after the decimal point. But as soon as you start having some, and then the error might not show up until much later, until it accumulates above a certain level, right? So these bugs can be hard to find if you are not careful. So, and in C, it may give you warning in the case of printf because it's the compiler takes special care of checking these for you. But in other cases, see, there is no type information in the source code. You have to know what type each expression is. So this is very important. You need to be in complete understanding of not just what's on the screen, but what attribute, what type attribute is associated with each, not only variable, but expression and their evaluation order.